My name is Constance, and I'm a product manager at Astronomer. So I'm going to be talking today about the shift to data-aware orchestration. So I first wanted to start off with the evolution and a quick history of Apache Airflow. So Apache Airflow is 10 years old this year. Woohoo! So it was created by Airbnb in 2014, and it became, in 2016, an Apache incubator project. In 2019, it ended up becoming a top-level project, and at least based on experience, this is really when we started to see a lot of enterprise adoption and Airflow in really cool places such as banks, pension funds, and some interesting financial institutions. I say this because I was one of these people, ultimately speaking, that helped to bring in Airflow into a financial institution. I think to this day, they probably are not super happy with me. But it's wonderful the project has grown even more. In 2020, that was a massive milestone because we released Airflow 2.0. 5 years later, we'll be releasing Airflow 3.0. So as of September 2024, we average around 25 to 30 million downloads, and we have 3.4 contributors. There's 36.2 GitHub stars, and we have roughly 45,000 Slack members in our community Airflow channel. So needless to say, over the past 10 years, Airflow has grown massively, and it's become the de facto standard of data orchestration and workflow orchestration. So why has it become a success? Well, really, it's been so successful because it is super flexible as a workflow orchestrator, and it focuses on tasks. By focusing on tasks, people can represent any arbitrary workflow and really do almost anything conceivable. As long as you can write your workflow in Python and your tasks in Python, you can do whatever you want, not just anything data related, but you can use it to set up infrastructure. You can use it to, as one of my friends did, set up the Christmas lights. And really, like I said, what's really cool about working at Astronomer is that we see so many different use cases outside of data. At the same time, data growth has grown massively in the last 10 years. So at this point in time, at least according to Statistica.com, we're projecting in 2025 to have data volume as 181 zettabytes, which I didn't honestly know was a thing until I found this graph. That's being produced, which is really a crazy amount of data when you think that in 2010 it was only 2. So there's been an exponential growth, and a lot of that is being orchestrated by Airflow. When we look at our community survey as well, we see that the majority of users are data practitioners. When we asked them what features they wanted to see, I mean, DAG versioning was number 1. We know this. It's been every single survey the top feature request. But then when you look at this next feature request, it becomes really interesting because we see that people wanted more data lineage in Airflow. We see that they wanted more support for data sets and data-driven scheduling, and we see that they wanted some sort of data cataloging services in Airflow. Now, traditionally, that's not been what Airflow has focused on. It's really been a workflow orchestrator. But as TP and I will be talking about, we plan to bring some data awareness into Airflow and build on top of data sets. So I want to talk about pipelines at this point in time, and I have a really toy example for a task-oriented pipeline. So this was written by the Python operator. I'm not going to show you the code because really it's just toy code. But this pipeline goes and it processes a bunch of orders. So it takes raw orders from an S3 bucket, and then it writes them to a staging table. Then after that kicks off, there's another 2 tasks that will go and take that data, and then we'll update a customer list, and it'll update also revenue by product. As I said, this is a simple toy example, kind of based off of the Jaffle Shop, and I'm sure most of you guys know it at this point in time. But really it highlights in a task-oriented world how a lot of people write their pipelines. So in 2.4, we released data-aware scheduling, and we tried to bring some data observability into Airflow itself. So this is not a real graph, just to preface, but I just wanted to highlight the example a little bit, where basically what you were seeing is that it's the same code again. We're taking the staging orders, we're processing them, and then we're writing them to an orders table. And then once that DAG finishes, we're updating the customer table and updating the revenue table, and then outputting that to the customer table and the product revenue table. So by including this, Airflow now has a little bit of a sense as to what data is being manipulated and the relationship between that. Now, this was great, but it's really a lot of boilerplate code. And as a data engineer, typically what's important about this is the data set itself, and it's the relationship between the data sets. So what if we could have asset-oriented pipelines? It's really, again, the exact same code. It's just a bit of a different positioning. So You have a DAG that writes to the orders table. You have the DAG that writes after that kicks off to the customer table, and you have a DAG that writes to the product revenue table. Again, exact same code, exact same granularity, exact same item potency, but now the focus has shifted from the pipeline that's generating the data and processing it to the data itself. And what becomes interesting when you start to see the world like this is that you can, and when Airflow knows about it, is you can bring in a lot of really cool things like block level lineage, or even orchestration, make orchestration decisions based on what the data has done previously. So what I mean by that is that if I can see, for example, that the orders table was backfilled and updated, then automatically I could set up a DAG to then go ahead and update the customer table and the product revenue table because it's aware of the relationship and it's specifically aware of the relationship between one run and the other runs and how that affects the table. So if there's one thing I really want you to take away, at least in this intro, is that by shifting the focus to data that's produced, we can do a lot of really, really, really interesting things and build upon that and bring data observability and data awareness into Airflow and make that a first-class citizen. Now, you're probably wondering how we're going to do that, and that's why I have TP. So we have 4 different AIPs, in case anybody is wondering. So there's AIP 73, which is an umbrella AIP. For expanding data awareness, and then we've got data assets, an asset-centered syntax, and then asset partitions. Now, TP is going to go ahead and go more into detail about each one of these.
You probably don't realize, but this slide deck is made by 2 people independently. So, and this is the first time I see in action as one slide deck. So I'm going to just go back a bit. So what you're seeing right here are things you produce, basically, or things you are trying to consume. And we want you to have 2 more important information on this. The first is the name of what you're going to call this inside Airflow, and the other is what is this exactly. So in this example, you have 3 things called data sets. Basically, this is data that I'm going to consume, but you might be able to have other kinds of things. For example, if you do Gen AI and kind of stuff, you might want to have a model or something, or a thing that you want to train on, whatever. So, and also another thing, Airflow already has a notion of a thing that's called datasets. We added that 2.4-ish, well, a long time ago, but nobody really uses them until pretty recently because, quite frankly, until pretty recently, it's the functionalities aren't really there for any practical use cases. I see a lot of nodding heads, which is not a sorry about that. So going back to datasets. So what we're trying to do, the first thing we're trying to do in 3.0 is to sort of make the dataset a bit better. So continue the current trend, so it's more useful for people. But in doing that, the first thing we realized is the name dataset is sort of wrong, because, oh my God, I see a lot of nodding heads already. Because dataset is for data, but you really wanting to represent more than data inside Airflow. So we're basically doing a rename. This is currently in progress, and it's only by actually renaming the thing I realized we actually do call a lot of things datasets inside Airflow that are not really datasets. So yeah, this is going to hopefully make things a lot easier. And aside from just renaming, we also want to do 3 more things. Okay, so a bit more on renaming. We're going to call it assets, but sometimes you still want to have datasets as assets. So I'll get back to that a bit. Okay, so rename. Another is you're going to be able to name the thing in a more user-friendly way instead of just having a URI, which is useful in some cases. I was almost going to say useless, but it's not. Okay, so more useful in more cases, especially in the UI. You're also going to be able to group your assets, or maybe more precisely, you are going to be able to assign a category to the assets you are defining in Airflow, and you can say this is an data set, this is a model, this is the blah, 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 whatever you want. It's basically just a string. It's similar to the name. And those things are going to show up in the UI. And by UI, I do not only mean the web UI, but also the REST API, the like custom view plugins, the user interface, that the Python code you interact with in DAX, and also there's one other thing. Oh, the CLI. Yeah, like those things should show up in user-facing interfaces, so the asset is more natural to use, and you don't feel like a machine that is just like interacting directly with a very long string that's the URL. All right, so this is what you're going to be able to do in 3.0 with all those additions. But this is not really that different from what you're already doing right now. It's just like different names and more attributes. But this gets you an idea of how much more information you will be able to put in to asset and be able to see in the UI. And unfortunately, I'm not going to show you a UI because that doesn't exist yet, but we are going to, by we, I mean Brent, is going to figure it out. Also, another thing that shows that the slide deck is made by two people is that I'm using different task names, so please just overlook that. This is the same, this should produce the same graph that Constance showed in the previous graph. With those new additions, like we should be able to like package the entire feature in a better way. So like this is a lot of code in the previous slide. So you should be able to just sort of do this, because if you recall the graph Constance showed you, like there were only like 3 boxes interconnected. And this was a lot of code for just 3 boxes. And this looks like 3 boxes. Right? Basically, you are defining an asset that's 1 box, and you give it a group name. So like there's a tiny label shows beneath the name that shows it's a model. And you can do like more things, and you can do schedule, things like that. If you were at Ankit's talk yesterday, he talked about how you can do like or and and in schedule, and that creates a like dependency between the things. And one more thing we're going to do is currently an asset is basically defining outlets, but you should also able to like read those outlets in a dependency task, and this is what these 2 are for. Basically, by giving an argument like named the same as the URL, you will be able to refer to those. Like this is important if these 3 things are in different files. All right, but aside from the repackaging, is still like the thing you define, the function you define that's decorated by an asset decorator is one is still a DAG. It's schedulable, so all the existing scheduling things will work. It's like daily, timetable, cron, data set triggering, it all works the same. It's still a task, so you can still put whatever you want inside that function. You read your data, you write your data, you do whatever you want, run a for loop inside. We don't care, it's just a Python function. Or I guess in 3.0, it can also be a function of a different language, which people talk about a lot. But the more important thing is also an asset. So you don't need to like define your asset somewhere and just reference it in a DAG or a task. It automatically becomes an asset that you can reference somewhere else, which like allows you more naturally to think your workflow as an asset instead of a like indirectly as a workflow that generates an asset that you use somewhere else in another workflow, which is like more complicated than it should be. Right? It's a DAG, so you can just put schedule, any kind of schedule, and you can also just reference it. This is how it will look like. We will probably accept like more complicated things than this, but this is just an example of what you can do. And you can also use these as inlets. So like this still has an URI, so you can use that to actually read and write your data. Right, DAG level definition. So this is DAG, but or like more precisely, is not a DAG. It's at the same level as a DAG, right? So like DAG is traditionally the highest highest level of definition you can have in Airflow. This is the second like concurrently highest level thing you can have in Airflow. So we'll probably also need to figure out some of the like wording in documentation, because like currently we say DAG file, but now you can have a DAG file without DAGs, which does not make sense. So we'll figure that out. I will need to. You probably can tell I haven't. Instead of defining like verbs that are tasks that do things, you can have like noun-based definition, like because what you define is actually an asset, not a task that generates an asset. So you will probably want to rename your functions to be like, this is a table instead of this generates a table. And another thing I'm going to talk about in the next section is we are going to also separate schedule and partition, because one thing I hear a lot, including during the conference, is dataset triggering is a bit too primitive, because like sometimes you have too many things generating at like in quick concessions, and you want to just like batch things together and just like just hold on a bit before you actually trigger a diagram, because there might be more coming in. So that I will talk about in the next section. But before that, I want to emphasize the one thing we are not doing in 3.0 is assets still don't write themselves. By that, I mean currently, if you want to create an outlet, you need to actually write the thing to the outlet and then define things that define the text that it generates. I declare this task, write to this thing, and then in the task, I need to actually write to the thing. This is still the same in like within the 3-4 AIPs. This does not change. You still need to do that manually. We are not happy with this, but they already like Vikram and Jarek already mentioned, we should be able to ship this next January. And if we do also do that, we are likely not going to make the deadline. So we're going to cut it. But if you're interested in this, please just come talk to me. I am still very interested in making it happen. And if we get more help from the community, we might make that happen sooner. All right, so going on to partitions. Constance told me that if you mention the name partitions, people will get the wrong idea. So I'm going to just skip this. All right, so the idea is like if you mention partitions, people remember what like other partition that other definitions of partition is. So we're not going to like. I'm going to just explain the idea and hope you make the connection. So I have an asset and I write to it, and this sort of represents that idea. What happens if I do a second run of the same asset? Like I run the asset function a second time, like this, right? The previous write is sort of like hidden in the background, discarded or overwritten or something, and this goes on and on. Third write, but this is almost never what we actually want. What we want is like there's a table that I want to like continuous write into, and if we want to do that and we want to have that information represented inside Airflow, we need to provide Airflow some additional metadata. So like both Airflow and other people reading the workflow I define understand what the workflow is actually doing. So this dotted line is the asset as a whole. And the first write writes a part of the asset. And the second write writes another part, and so on, and so on, and so on. Okay, this is good. What's missing in Airflow? Basically a way for me to say like what are these lines are. So what separates one partition to another, right? After some like pretty heated back and forth conversation, we ended up with basically 3 kinds of ways you can do that line. First is time-based. That's the easy one. Basically, you just like, I do this every day, so just cut every midnight. That's easy. Or like, basically whatever you do with the cron expressions. Second is basic data groups. Essentially, this table actually represents three things that look very similar. For example, like you have a lot of divisions in your company, and you want to do basically the same thing for each division, but those divisions are still sort of separated, so you want them to be represented separately inside Airflow. That's called I am calling data groups. Like if you have better names, like the one thing I do the worst is naming things. So come to me with better names if you have them. The third one is serial number. It's similar to time-based, except you don't use a time. For example, like I want to slice every 100 records or so, or like I want to slice at a certain time, but I don't want to use the time. Like I want to slice every day, but my table does not actually have a timestamp. So I need to like, it has a serial number instead, and I need to like have a way to map the time to a serial number. But I want to slice using serial numbers instead. And that's the third one. So basically 3 kinds of ways you can do partitions. The other 2 are like useful, but I don't have, how much time do I have? Oh, not much. So I'm going to probably skip those 2. But fundamentally, because we are trying to define partition as a very like generic idea, those 3 should work the same. So I'm going to just focus on the first one. But if you focus only on the first one, you like sort of realize like this actually exists in Airflow. So the next thing we come to is partition is not new. So Airflow has partitions. We are just going to like just generalize the idea a bit more from what it currently is and gives it a better name so people like potentially understand it better. So what is the thing that Airflow has? It's called execution dates, which is controversial, I guess, based from the reaction. All right, so who actually understands what execution date is? All right, that's about 1/5, I guess. So this is a catch up for everyone that still doesn't. You're not going to need this in Airflow 3, hopefully. So this is going to be useless. It's only for like intellectual like curiosity sort of thing. All right, so this is a DAG that runs 3 times. For run 2, it should cover the time period between run 1, because run 1 should have processed data prior to the date. So run 2 should cover the period between run 1 and run 2. I'm assigning those dates as alpha and beta. And so run 2 has a partition of alpha, like between alpha and beta. And in Airflow, that is represented by execution that equals to alpha. I didn't make that decision, just to be clear. All right, so that's confusing. So in, I don't know, 2.2 or something, we introduced a concept called data interval. And data interval like actually has both values in the construct, so you can actually know that run 2 is supposed to represent alpha and beta. Okay, this is good. This solves this one problem, that execution. This is also why we are trying to kill execution date, because theoretically it should be like conceptually replaced by data interval. But yeah, I'm going to not talk about that too much. So what we're actually going to do, like by introducing partitions, is to basically just rename this to partition key. So instead of hardwiring the concept of partitioning to dates, we are going to just say, hey, this like run 2 handles a partition of this asset, and that partition is going to have a key alpha beta. And Airflow does not really care what alpha beta means. Those are just 2 values, actually just one tuple of 2 values, so just 1 value in Airflow. And it will just show you that, and you are left to figure out what that actually means. So this might sound weird that Airflow is actually doing less, but by Airflow assuming less, it allows you to assign whatever value you want inside the partition, which enables you to slice in better ways. For example, in this simple example, you can only slice by this is the previous run, and I'm going to have a slice of this and that. But that might not always be the case. You might want to actually slice the previous run. So you can do a sliding window or something. or you might want to, like I mentioned, batching. So when the partition ends, I might not want to let run 2 just handle that just yet. I may want to just wait a bit because those data might still change. So I want to wait a bit until run 3 to handle this section of data. So I am free to define that run 3 has a partition alpha beta, and only run 4 has the partition of beta gamma, which you can't do with data intervals. All right, so partitions simplified because like it no longer has that weird like one value represents a range, which does not make sense. Generalized, so you can do more with less. That sounds too much like Apple. It's also independent. You don't necessarily need to slice by the schedule. You can have independent definitions between the schedule and the partition, so you can like have very like a lot weirder combination. If you actually read the AIP 76, I think I mentioned a ton of very weird, contrived ideas that I had have different partitions with schedules, and the feedback I got is basically, is anyone ever going to use this? I have no idea. I'm not an Airflow user. I only use Airflow like because I need to test the things I implement in Airflow. That's the extent I use Airflow. So I have no idea what everyone's use cases are. So if like I encourage anyone to try to break this thing. All right.
That's why I work with them.
I give them the use cases.
Yeah, so I don't go rogue too much. Just try to implement whatever like challenge I can think of as. All right. Good segue.
So we threw a lot of information at you. And so really there's a few takeaways that I really want you guys to have. I mean, first one is that really Airflow is evolving to meet the needs of modern data workflows. Ultimately speaking, we want to make data and data assets a first-class citizen in Airflow. We want to enable you to be able to understand the relationships between different assets, and specifically the data that is manipulated in one task versus the data that is manipulated in another task, within the same DAG, within separate DAGs, within separate Airflow instances. We want to be able to provide you ultimately lineage and a global understanding of the data that's being manipulated, like I said, within Airflow. The second thing is that data assets and partitions are how we're going to do that. Like TP mentioned, data assets are meant to represent the things that you interact with, so your data products. So that could be your data sets, that could be your ML models, that could be your reports, it could be your dashboards. It's really anything that is important to the business. By bringing that visibility into Airflow, it means that you'll be more responsive when your stakeholders call you at 3 in the morning to tell you, why did this thing go down? Secondly, with partitions, we're introducing that so that we have a clear understanding of the relationship between the task instance, so the task that was basically that is manipulating the data, and the slice of data that is there. So partitions is really the key, and it's the key for us in understanding that relationship. Once we understand that relationship at the task level, it's really easy for us to extrapolate that amongst different workflows. That's going to give you more granular control ultimately and a lot more transparency within Airflow. And really, this is not to say that, you know, if you want to go ahead and orchestrate your Christmas lights with Airflow, you're still going to be able to do that. But ultimately, given the users of Airflow and given the use cases that people are asking us, the big push that we're doing at Astronomer is for making orchestration a lot more data-centric than it is today. Thank you very much.